Okay, for question 1, I had the question: calculate the pH of 50.0 milliliter of 0.200 molarity solution of hydrochlorine after the following amount of 250 molarity of sodium hydroxide have been added. For question 1, I have a milliliter of 30.4 sodium of hydroxide. What I first did was convert 30.4 milliliter by 1000 gives me 0.0304 liter, and I use the unit conversion to get the mole of sodium hydroxide, which gave me 0.0076 moles of sodium hydroxide. And I then did a second part, which was 0.050 liter. And I did the same thing as the top. I multiplied it, and it gave me 0.01 mole of hydrochlorine. And when we're looking at this, I can tell that 0.0076 mole of sodium hydroxide is the limiting reactant because of the smaller number. And so next we do is we find the leftover, which is basically subtracting both moles, giving us the leftover mole, which is 0.01 mole of hydrochlorine minus 0.076 mole of hydrochlorine gives us 0.0024 moles of hydrochlorine. And so we're not finished yet. We still have to find the concentration of hydrogen chlorine, which I did with the leftover mole, which is 0.0024 mole of hydrochlorine, divided by the volume base and acid, which is 0.050 plus 0.0304. And what I do with it is I added both of them and divided by 0.0024, and it gives me the answer of 0.0299 moles of hydrochlorine, which also gives me which also let me know that 0.0299 moles of hydrochlorine is an acid, strong acid. And so what I did next was I went to find the pH, which is minus log and bracket of hydro plus equals to the log of log bracket 0.0299 molarity of hydrochlorine gives us the answer of 1.52, which is a strong acid because it's less than 7. And for the second question, I had the milliliter of 61.2 milliliter of sodium hydroxide. And what I did first was I did the unit conversion again with 0.0612 liter into 1 part of a liter solution and into 0.250 moles of sodium hydroxide, and that gives me the answer of 0.0153 moles of sodium hydroxide. And since we know that the hydrochlorine is the same as up here, we know we're going to take that down here, and it becomes 0.01 moles of hydrochlorine, which is definitely a limiting reactant because it's less than 0.0153 moles of sodium hydroxide. And so for this one, we know that the pH would be higher than 7.00. And so what I first start is I start with the 0.0, well, we find the leftover, which I start with 0.0153 moles of sodium hydroxide minus by 0.01 mole gives us the answer of 0.0053 moles of sodium hydroxide. And now we need to find the concentration of sodium hydroxide, which is the same thing as the leftover amount of sodium on hydroxide into the total volume, which is the same step as hydrochlorine. What I did was I added the volume of both acid and base together and divided by 0.0053 moles of sodium hydroxide, which gives me the answer of 0.0477 moles of sodium hydroxide. And then I have to find the pOH, which is the log bracket hydroxide negative, gives us the log of bracket 0.0477 moles of sodium hydroxide, which gives us 1.32. And we're not done yet because we still have to find the pH. So pH is 14.00, and we subtracted by the pOH. We subtracted by the pOH, which was giving us 1.32. We subtracted by 1.32, and it gave me an answer of 12.68, which is a strong base.